I'd like to introduce myself. My name's Carl Baxmeyer. I'm a educational planner with Wightman, do demography and a lot of master facility plans. And I'm going to be the moderator and facilitator today. Let me just say that we started this series of town hall meetings shortly after the pandemic hit last year. And it really has been a platform for superintendents, administrators, teachers, and others to share information, become informed, and we've enjoyed having this opportunity to share best practices among the participants. Today we're going to talk about what schools should consider when considering COVID-19, indoor air quality, and energy efficiency. Is it one or all three? And to present that and start the discussion, we're so pleased to have Dr. Lisa Ng, who's a mechanical engineer with the National Institute of Standards and Technology. And Dr. Ng focuses on indoor air quality and ventilation research. With us also is Ian Haddon, Director of Energy Management at the University of Arkansas at Little Rock, and focuses on sustainable design, energy efficiency, and indoor air quality. And we're so pleased to have both of you with us today to kick off this edition of Wednesdays with Wightman. And with that, I'm going to turn it over to our two presenters to first present and then open it up for discussion. So Lisa, Ian, it's all yours.
Great. Thanks very much, Carl, and thanks everyone for joining us today. So, we'll talk about, what is the balance point that we're doing with indoor air quality, energy efficiency, and dealing with COVID-19. As we start this discussion, just a couple of things to kick off is just to kind of get a common definition of what indoor air quality is. And this comes from EPA Tools for Schools program, and it looks at being the nature of the indoor air as it relates to the health, well-being, and the productivity of the building's occupants. So that's kind of our starting point as to what we're looking at for indoor air quality. There are four primary factors that impact the indoor air quality in any sort of building or space, and that's controlling the contaminants and the source of those contaminants, managing humidity, filtration, and then ventilation, dilution through introduction of fresh air. If you aren't sure of some resources, there are some great resources out there, even from the U.S. government. The EPA, their Indoor Environments Division, is just a wealth of information and some fantastic folks there. So many years ago, they started with developing the Tools for Schools kit. It gives you a great framework for effectively managing your indoor air quality program. Works through the 6 technical solutions that you see highlighted there, and it focuses on trying to get that framework of how you organize, communicate, assess, and do that kind of circular planning around your action kit. It's very, very user-friendly. It can be tailored to whatever your needs are. But lots and lots of great information and a fantastic community to be part of. So with that kickoff, I'm going to turn it over to Lisa and let her talk about some recent research that they've been doing at NIST.
Yes, thank you for the introduction, Ian, and thank you, Carl, and the rest of the Wightman team for having me here. Again, I work at the National Institute of Standards and Technology, and the focus of today's presentation is to talk a little bit about the research, but to really drive home the point that we can address COVID-19 issues now with proper ventilation, enhanced filtration, and we can improve the indoor air quality overall. I would like to note that while the virus itself is very small, it takes a ride on particles much larger than itself. So if we can ventilate our indoor spaces and we can filter those particles out, we can reduce our exposure inside buildings. And I see Donald put number 5 in the chat saying that they don't really know what the indoor air quality in their schools is. And as a parent myself, I feel that pain. Our district did take steps, and I'd like to highlight the research that supports their decisions and how that air quality has been improved now and for the future. So next slide, please. So we did our study on schools. And we focused on the objective of looking at HVAC as well as non-HVAC controls to reduce exposure. And we're going to talk about it in a relative sense. The next slide will show some disclaimers. You know, these numbers don't say this is a healthy building, this is a safe building. This is merely to say we can reduce our exposure from a baseline, which is no controls at all. Our simulations were done on single zone classrooms where the concentration is uniform throughout. So unfortunately, we didn't look at, you know, where to put a portable air cleaner, where to put, you know, where, if you're designing a new building, what kind of system supplied return situation you should have. These are for single zone systems with uniform concentration. And again, these should be part of a larger risk strategy. So even though we address ventilation and filtration, we can't deny that there are ASHRAE as well as CDC still saying social distancing, hygiene. Those things matter as well. So the next slide will show, this is the tool that we use. This is a tool that we developed last summer. It's called FATIMA. It has user input, so you don't need to work with our simulation model. It does the simulations in the background. If you know basic characteristics of your zone size, your zone system, you can use this interface. It is free to use, so there's going to be links in the slides that you can access. It will also calculate your air change rate given your system flow. So if you want to know, you know, what your air change rate based on your volume of your space and the CFM or liter per second here, it'll calculate the total outdoor air change rate right there for you. Next slide. So our study, I keep on going. Thank you. So we looked at 3 different classrooms. The 2 of the classrooms, they're slightly different sizes. And then we looked at a really large assembly room. So this could be a multi-purpose room. In my kids' school, it would be the auditorium / cafeteria / aftercare space. So any of these large spaces where the ceiling height is much taller than your typical classroom. And these are ASHRAE 62.1 2019 rates. So we are assuming that they're at least meeting the minimum standards. And you can't say that for every school in every situation, but we're going to assume you're ventilating at the minimum requirement. Next slide. Again, the virus is smaller than 1 micron, but we looked at particles that are 1 micron. There's also things in the air that are bigger and smaller than 1 micron. So we chose a single size, one, because the tool itself is only capable of modeling 1 size, but this also focuses our attention on, you know, what a specific filter will do with 1 particular size. We also simulated an emission of 500 particles per minute from a contagious person. This number is not what's in the literature. And it doesn't matter as much for our study because we're looking at normalized results, meaning exposure from baseline. So this 500 number could be 5, it could be 1,000, but that percentage reduction in exposure is going to be the same no matter what that particular number is. Next slide. So we did this study and we looked at several types of controls, which included masks, outdoor air ventilation, the use of a portable air cleaner. So these are the portable units you can put in your classroom. The MERV rating, the filter rating. So the higher the MERV number, the better filtration capability it has. And then the use of exhaust fans. And when I say exhaust fans, I mean like portable box fans that you could purchase, you could put in a window to supplement any mechanical ventilation that the school has or doesn't have. Next slide. We also looked at different types of systems because not all schools have the same ventilation system, but we looked at a central system, which is here on the left. We have the 100% DOAS system, which Ian will highlight in his presentation. So this is a DOAS system supplying air directly to the classroom, and then there's a separate unit in the classroom doing conditioning. The next system is a terminal unit system. So this is very similar to the DOAS, except it brings in outside air through that terminal unit. And then the last type of classroom we have is one that doesn't have mechanical ventilation at all, which we know exists in our older classrooms. So we won't talk about all the results from all these systems because of time, but there's a link to the full report, lots of tables and data if you want to look to help your school, your situation, look at the different controls that are possible and the level of exposures that you can achieve. So next slide. So let's just talk really briefly about some of the results. So here we have the 2 classrooms on one graph, the assembly room on the other. All the values are the integrated exposure over that time divided by the classroom with the lowest exposure. So in this case, your central system had the lowest exposure of all the HVAC systems that we simulated. And that's because it had a higher base MERV filtration, a MERV 8 filtration, and also recirculated less air than the other classrooms. But you look at the DOAS system and the terminal unit system, they both have very similar integrated exposure compared to that central system. Their filters were MERV 6, and they circulated a little bit more air than the central system. And on the very right, you see that for your window unit system, which had no mechanical ventilation, unfortunately, they start off at a much higher level of integrated exposure than these other systems because it doesn't have filtration and it doesn't have outdoor air. But that's not to say there aren't controls that can help reduce that exposure. I don't show the results in this presentation, but you can see that portable air cleaners are very effective. And also exhaust fans are very effective in these spaces that don't have mechanical ventilation and don't have anywhere to upgrade a central filter. Next slide, please. Thank you. So with controls, I'm going to focus on the classroom here and the terminal unit system. So this is the one where the outdoor air is coming directly into that space through a fan coil or some sort of unit ventilator in the classroom. And this graph shows for each individual control by itself, what kind of level of exposure you can get. So you'll see that there's a very large range. So the top of the range is when the control is not working properly or not working as expected. And then at the bottom is when the control is working at its best. So you see that the mask and the MERV 13 alone can reduce exposure very similarly around the 50% mark. And then portable air cleaners with the HEPA filter in it, this is a 300 CFM portable air cleaner, can reduce that exposure 40%. But when you combine controls such as MERV 13 with the mask, so everything on the right is the control with the mask, you can see that the controls perform better. So you combine the two, you can get a lower exposure. And if you combine all of them together, you get the lowest exposure. I did want to point out this exhaust fan, it does look like that it's reducing the exposure the most, but keep in mind, this is a 1200 CFM exhaust fan, which translates to 10 air changes. So that's a very high exhaust rate. And we have to keep in mind that when you have an exhaust fan that large, you have to keep in mind where that air is coming from. Is it coming from adjacent spaces? Is it coming from corridors where there may be contagious agents or other particles? Next slide, please. And then this is for the larger room, the assembly room, also a similar type of system. And you can see here that masks are going to perform similarly, whether it's a small space or a large space. MERV 13 filtration is going to perform not as well because of the large space, but you can see for the same size portable air cleaner and exhaust fan for such a large space, that control isn't appropriate to reduce that exposure as in the smaller spaces. So when you think about controls, you want to think about the size of the space, as well as the HVAC system that's already in there and its capabilities before putting in these large fans that may not be as effective because the space is so large, or you may need multiple units in order to achieve a reduction. Next slide. And this is looking at all the controls with masks, and we wanted to compare them with MERV 13 filtration, not because that's the magic number, but that's because a lot of the organizations that put out standards for ventilation, such as ASHRAE, do specifically call out MERV 13. If it's possible, definitely consult your engineer. Don't do anything to your system that would harm the system or harm your occupants. But we just wanted to look at a comparison of MERV 13 filtration across these different levels. So you'll see on the graph, the triangles are the MERV filtration, and the last triangle there is MERV 13 filtration. And you'll see that the portable air cleaner needs to be a pretty high level. Here, it's close to a 450 CFM portable air cleaner to match a MERV 13 filtration level of reduction, or an exhaust fan that's somewhere between 600 and 1000 CFM. So this is just to point out that there's multiple ways to get to where you want to go. There's not just one simple answer. If you can't, if your system can't handle MERV 13, if you can't purchase a MERV 13 filter, there are other ways to get there. And hopefully this is a good news kind of presentation where it's not just a single way to get to lower exposure, but multiple ways. And again, we can solve for COVID now and address problems in schools in the future, such as particles, which can cause asthma, which can exacerbate asthma, as well as other respiratory diseases. So next slide is going to show that same results for that really large assembly room. So in my kids' cafeteria slash multi-purpose room, a single 300 CFM portable air cleaner is not going to cut it. You're going to need multiple ones. Same with the exhaust fan. We tested up to an 8,400 CFM exhaust fan, and it didn't reduce exposure as much as a MERV 13 filter for that space. So next slide. So the summary just wants to we just want to reiterate that the effect of your control is going to depend on multiple factors, which include HVAC system type, the size of your space, and it's also the control itself. Mask fit is very important. How you set up that portable air cleaner, if you run it at a low setting versus a max setting, you're not going to get the result that is on the website. As well as filter fit. MERV 13 filter is great, but if you have leakage all around it, then it's essentially not a MERV 13. So again, we are not saying that using these controls will get you to a safe or to a healthy school, but it can reduce the exposure to COVID-19, as well as to a number of other contaminants in the air, which have nothing to do with the pandemic, which are in our schools, whether that be dust, paint materials, art supplies, cleaning supplies. So we can definitely address all these things with improved ventilation and improved filtration. And if you want to read the wonderful report, click on that DOI link over there. But yeah, all the information that you're going to want, executive summary, and also the tables in the back, it'll list every control and compare it to baseline and how much you could potentially reduce your exposure. And for me in our schools, they have implemented MERV 13 filtration and portable air cleaners. So for me, they're taking a step direction. And with these simulation results, I can see how that can all compare. So with that, I will turn it back to Ian. Oh, Ian, you're muted.
Yep, I'm good. I just caught that. So thank you very much, Lisa. And again, like you, it's a pleasure. I had have a prior experience working with Carl and with a couple of other folks at Wightman, and they're it's a treat to be able to get back to work with those folks again. So if we shift our focus away from the great research that Lisa and the folks at NIST have done, and kind of look at this, not new idea of how do we balance our priorities. I'm sure lots of folks have seen graphs such as this, and this is actually, I didn't realize it, but this comes from a National Bureau of Standards book, which is the predecessor to NIST. Lisa pointed out as we were prepping, but trying to find those balance points where you get the optimum performance in terms of life cycle cost, investment, and energy cost, and those things continue to work around all that we're going to do. So in terms of indoor air quality and energy efficiency, one of the things to remember is that 70 to 80% of a building's cost comes after its construction. It's the people, it's the it's renewal of the capital investment, it's the utility cost, it's all the maintenance, it's the custodial, it's cleaning the floor and waxing the floor. And building efficient buildings, or renovating and recreating efficient buildings when you do that capital improvement, really is a key to controlling your long-term costs. And I heard this quote many years ago from what I've deemed as a really wise K-12 facilities manager. And he had, over the years, he had preached to his school board, and they had really bought into it, that they, as a school district, were too poor to build cheap buildings. In that, if we build something that is not energy efficient, that isn't durable, that isn't easy to maintain, our costs to do that are going to go through the roof, and we are, shooting ourselves in the foot before we even start. So I've always thought that was a great nugget from that. I just wish I could remember who it was. A couple other resources that are out there for you. EPA Energy Star, if you're not familiar with it, is a fantastic program with their portfolio manager. It gives you a tool to at least start tracking and trying to understand and manage your energy, measure it over time. That old axiom that you can't improve what you're not measuring. So this is a way, and it's a low cost, no cost way to do this. EPA doesn't charge you any money to use Portfolio Manager. It's just the time investment to get things set up and to track your utility costs. And the program also, not just from you, but it also has Energy Star Challenge parts. It has student engagement components and resources as well for kids. So, it really does have a good fit within the K-12 environment. So let me touch on maintenance a little bit, and y'all can read the highlights here, but I'll share. Years ago, when I worked in Arizona, there was a school district down in the southwest corner of Arizona in the town of Yuma, and they had to close one of their schools for a little over a school year. And it was because of a mold infestation, a mold breakout in their building. And they figured out that what the root cause was is that they hadn't paid very much attention to their maintenance. They had hired somebody. I believe they may have been either a retired custodian or a side business of one of the district custodians, and that they hadn't done a good job of monitoring what types of filters were going into the HVAC system. The person was putting in the cheapest filters they could find, and really weren't trapping any dust or very little, and it allowed dust and dirt to get all down through the HVAC system. And even in Yuma, that you might think is a really, really dry environment, but they are sitting actually on the tail end of the Colorado River, and they do get some humidity during different parts of the year. And they had a mold outbreak even down in that environment. So, maintenance is a key idea. And it really, one of the things that I always try and stress with folks is that it really is a focus on the safety and the stewardship of the investment that you're making in your student, staff, and facilities. So regular preventative maintenance, really get religious about those filter changes, invest in your building staff, getting them the proper training as to understanding why you have certain filters in different applications. Just as you would train your teachers or any other person that you would have in your district, make sure you're doing that with your building and maintenance, your custodial staff, et cetera. Make sure you're doing the other manufactured recommended maintenance, whether it's cleaning coils, et cetera. And then a simple one is take a walk around your building and look at where your outside air is coming into the building. Is it covered, is it down low to the ground because you have unit ventilators and the mowers have just been through and they blew grass, or it's the fall and all the leaves are blown up against the ventilation openings, or maybe even snow up in Michigan. So sometimes it's just walking around. Your building envelope is key, and keeping moisture out of your building. And it really doesn't matter. You can live, like I said, in Yuma. You can live in somewhere where you think you don't have humidity. It is an issue. It is always going to be an issue wherever you are, and your building envelope is the first line of defense. So when you're building a new building, make sure you're having a discussion with your designers about how the air and the vapor barriers are being done. And it's good for you to understand it as an owner, so that when you go to do a renovation, you can make sure that those things continue to be done correctly. It is going to be where they're going to be positioned is going to be based on your local environment. And then just continuing, as I said, walking around, looking for problems at your windows and doors and wall penetrations. And it will not only help your moisture control, but it also help your pest control as well, which will be another contributing factor to good indoor air quality. Ventilation is the largest single cost driver in terms of air conditioning, bringing in that fresh air, whether you're doing it in the heating mode or the cooling mode. That is bringing in and conditioning that outside air that it is either really, really hot and humid or really, really cold and dry, is going to be the largest single driver cost within your HVAC system. We're talking about over $6 billion a year, and that statistic is from the earlier 2000s, so I'm sure it's much larger now. And it's typically the second largest item after personnel. And so as we get more and more operations and more community engagement of schools, you have more operational hours. Well, that means more ventilation of the building is coming in when the buildings are operations. And again, we talked about the building costs coming after construction a little bit already. So this kind of gives you a picture of where the utility costs are going nationally in a school building load profile. Significant portion of it there is in your heating system, lights, ventilation, and cooling, and then water heating. So when you look at heating, ventilation, and cooling, you're talking about 75% and 70 to 75% of your total utility costs are being driven just by your HVAC system there. So it's an important driver into managing your utility costs. There are certainly mechanical codes, state energy codes that are out there, and it's good for you as as an owner to be informed about what are the current codes in your area. Are they, and realistically, we always have to think about a code being the worst possible building that you are legally allowed to build and not get sued. So if that's the bar that you want to be at for your buildings, great, then code compliant is where you want to set your bar. But if you want to be somewhere above code, if you want to have a better building, if you want to have a better learning environment, then you probably want to make sure that you understand what those minimums are and make the decisions as to where the investments are that you want to make that will help you get to those really good learning environments. And so the key there is just being an informed client. You don't want to rely just solely on your designers. There is a partnership between designers and owners, and it takes responsibility and investment and knowledge on both parties. So Lisa mentioned DOAS, and if you're not familiar with that acronym, it stands for Dedicated Outside Air Systems. And these are systems where you have a unit that is specifically designed, and the only thing it does is it brings in outside air. It does not, unless it has an energy wheel, but typically, often they don't. It is purely bringing in outside air, and it is going to filter that air. It's going to dehumidify it, and in a lot of applications, it will cool it or heat it back up so that it doesn't. It either provides no load into the space for any local requirements, or in particular in cooling modes, it can be used to supplement local terminal units or other systems that are out there. So this is kind of a graphic of what your traditional overhead delivery is. You typically design air, and during the cooling season, you supply it at around 55-degree air, and it mixes into the room. And during the heating season, it warms up a little bit, but still you don't raise it that much, maybe 65, 75 degrees, because if it gets too hot, then it really doesn't want to mix. It stays too buoyant and it sits above the ceiling, and you don't get the mixing and you don't get the ventilation circulating around in the space down to the occupied folks and to the breathing zone where the people are. So as Lisa said, this kind of goes back to her example earlier. In this example, you've got a dedicated outside air unit, and it's giving conditioned fresh air, and it's delivering it directly into that space. Ideally, each of those spaces, you'd have a terminal box, a VAV box, some sort of a damper box that would be able to control the amount of air so that you can put air into rooms that have occupancy in it, and then shut off ventilation air to rooms that don't have any occupancy. And that's another way that you can, manage your utility spend. So, if all of your third grade classrooms go to recess and then immediately to lunch, and they're out of their room for, an hour to an hour and a half, then that's a great time for, if your system is designed to be able to control and maybe reduce the ventilation going into those spaces to help manage your utility costs a little better. Another way to do it, if you don't have the terminal units, is to have the fresh air delivered to another unit that then serves the space. I know there's Michigan, I know, has a lot of buildings with in-room units, terminal units, unit ventilators, and those can pose challenges with the acoustical environment of the space. And so trying to have units outside of the space can be helpful. Just to give you an example of what can be done, and when you're dealing with energy efficiency, you don't have to go to the most complicated systems. You want to make sure that you try and find the balance point between an efficient system and a system that you as a district and your staff are able to maintain and operate. And so an example I was involved in, and Carl was a little bit as well, we were working with with New Orleans Public Schools after Hurricane Katrina, and working with them on developing their new design guidelines for all the schools that were going to be rebuilt. And the first study that came through was done by some other folks. They went and they tried to do every trick in the bag that they could think of to reduce energy and save energy. And so on the air conditioning system, they had variable speed drive water cooled chillers and cooling towers and rooftop VAV air handlers and DDC controls. And that all worked out to be about a 35% energy cost savings. When we went back and we talked with the district, and we got a better sense of what their maintenance capabilities were, we realized that cooling tower maintenance and water cooled chiller maintenance and big rooftop VAV air handlers were not things that they were really familiar with, and we wanted to go back. So the final system used an air cooled chiller. It did a dedicated outside air system with occupancy control. We used 4-pipe vertical fan coil units that were mounted with hallway access for double doors, so you had 2 units stacked to each other. DDC controls, and it had a 32% energy cost savings. So there is a wide range of options, provided that you are, have some knowledge and ask some good questions with your design team. You'll be able to find a solution that works for you and for your utility budget and for your maintenance staff. But part of that is going to be setting goals and working with the board and trying to, really encourage you to look at developing a written policy, figuring out what are the important items based on how they impact educational environment. You may decide that, ventilation and acoustics are the 2 most important things because of the massive impact they have on educational impact. Or you may prioritize a little bit more on maintenance. But the bottom line is figure out what your plan is, develop that plan, get it communicated to the board, to the community, and to the design team there. So this is a quick bit of an adopted policy from Dayton Public Schools from several years ago. And the state of Ohio has a policy where all the new school construction does seek LEED certification. And so this is partially driven by some of that information. So in terms of final thoughts, and I'll ask Lisa to chime in here if she has some other ones that I haven't covered, but really realistically, we want to talk about that these good indoor air quality practices do support the core mission of our schools, of delivering quality education to the children of our districts. They impact the educational outcomes so we want to make sure that they promote learning. A district's commitment from the administration and from the O&M staff is the first step and critical step in this process, because if you're committed to it, then your designers are going to be committed to it from that. And then you're going to be able to make those decisions to build for the long term, because your school assets are going to be around. If you're like me, I'm on a K-12 campus, but I got plenty of buildings that were built in the 1960s and before, and I've got some that haven't had HVAC system upgrades in almost 30 years. So I do understand the pain you were probably going through. And we want to be able to use our school buildings to do more than just teach our students. They should be a reflection of the value of the community as well. So Lisa, any other thoughts you wanted to add?
A little story. That's the one little tidbit someone said to me once is, you can have a building built in the 1960s operating optimally that performs better than the LEED Platinum school built last year operated poorly. So I really like that you
Absolutely
emphasize the maintenance as well. So those 2 are great points.
Okay. I think that gets us wrapped up. And so, Carl, I think we've got a chance for questions.
We do.
Yeah.
First, I want to thank both you and Lisa for participating today and for a really informative presentation. A lot of good information that districts can use. Why don't we go to the next slide? And if any of the participants would like to either use the chat box or raise their hand, I think somebody has already raised their hand.
I think Donald has. So
Don Wheaton has.
That would be me. I have a question for you with respect to using bipolar ionization to help neutralize viruses and things in the air. What's your opinion on that?
So we have had a fair amount of questions about that here on our campus, and our personal, I work with another mechanical engineer, and my boss has an engineering background as well. And everything that we have seen on that so far, we still believe that it is that it's a bleeding edge technology right now in terms of dealing with kind of viruses and other contaminants. It's certainly, ionization has a long history in dealing with odors, but there are certainly challenges in terms of ozone production and other factors that you do need to do it. So we have not made that investment, and very few of the folks campuses that I am aware of have made that investment. I'll draw that and extend it to UVC lighting as well. And similarly, we have seen, and we believe, unfortunately, we don't have it implemented on our campus, but we are very much believers that UVC lights are appropriate for surface decontamination. So within an air handler, pointed at the drain pan and at the leaving side of a cooling coil, very, very effective at helping control growth of mold and mildew and any other sort of contaminants. We have not seen that it can be effectively implemented, and certainly cannot be effectively implemented in a retrofit application of trying to sterilize a moving airstream. The intensity of the light that you have to produce to do that sterilization is just pretty exorbitant, and we have not seen that be effective. And so, Lisa, you want to add any thoughts there?
Echo everything that you said there, Ian. For bipolar ionization, I have heard companies say they're below a certain ozone threshold that's been set by by UL. Unfortunately, that doesn't measure hydroxyl radicals that also are produced, and these may create secondary byproducts as they combine with other things in the air. So you may be exacerbating IAQ issues because of these untested health effects that are not proven yet. And I'll defer to Ian on the UVC. There is some guidance on the ASHRAE website about the use of UVC, but I would have to say that ventilation, filtration, do those first, and we can talk about UVC and other technologies as a supplement, but not as the primary goal.
Yeah, that's a great point, Lisa. Just like in energy efficiency, the first step in energy efficiency is not going and buying energy efficient equipment. It's turning off things that you don't need to be running. So in terms of dealing with these issues, the first thing to do in terms of managing your indoor air quality is make sure your outside air dampers are working correctly. Make sure you have the appropriate filters in there. Lisa made the point that just because you can put a MERV 13 filter into a filter rack doesn't mean that the filter rack is designed for that, and that you won't end up with more leakage around the filter and turn that MERV 13 into a MERV 8, and you'd have been better off with a MERV 8 in the first place. So
can you repeat that word you said, hydroxyl? What was the second word?
Hydroxyl radicals.
Thank you.
Mm-hmm.
Yeah.
Yeah, and because our buildings were all built in the 1950s for the most part. And in fact, one of our buildings was built in the 1920s. But most of the buildings, like I said, 1950s, we are using unit ventilators for the most part. We have had a consistent maintenance program since we replaced them in a bond issue 20 years ago. We hired a company. They come in all the time. They check the filters and change the filters. They clean them up. They do all that preventive maintenance so that we don't have disasters in the making, as it were, or failures all over the place. But the question then becomes, can you put a high enough rated filter in the darn thing in order to filter like it needs to?
I think in that type of application, that may be where Lisa's research on the portable air cleaners is helpful. Unit ventilators can be a challenge. One of the things to possibly consider as you do your next major replacement and renovation of those is to supplement, is to
convert the unit ventilators so that they aren't actually your ventilation source, that they're more just the, the heating and cooling source, and implementing a dedicated outside air system. And I will say, some of those 1920s buildings, they are just absolutely gorgeous, and wonderful buildings with lots and lots of windows and high ceilings. So hopefully that's what you have in your 1920s building. And when you go renovate it, it can be some of the show places that I've seen renovated in schools before.
Yes, definitely. And like I said, MERV 13 is not a magic number. It's definitely a filter level recommended by ASHRAE. But our report does, show a line across the graph saying, if you want to perform to MERV 13, if there's people in your community who are saying MERV 13 for 13, there's ways to get there that aren't just MERV 13. And we can get close to it, but it's no magic number where you just want to reduce exposure, which is all we can do, because risk is never zero in any situation.
When you say an exhaust fan, an installed exhaust fan pulling the air out of the classroom and out into the outside world?
Yes, I meant something that you could put into an operable window to help move that air out. Yes, I mean, it could be a central fan, but oftentimes those are just bathroom or kitchen or cafeteria exhaust, and they're not in that space that students are in.
But it is, Lisa did mention it, you have to pay attention to where that air is going to come from, because you may create more problems than you are doing. If you've walked into buildings, I'm sure, that either have a single or double entry, and it becomes a wind tunnel as soon as you open the door. And if you were to go put box fans in all the windows of all your classrooms, you would probably create wind tunnels at all your door entries, and you're going to end up bringing in lots of uncontrolled air into your building through all the cracks and crevices. And that could create more mold problems behind walls, inside walls, than what you're trying to do in terms of the source contamination control and exhausting. Ethan, did you have a question?
I thought there was one more.
No, I don't have any questions.
Okay.
Okay.
I
Well,
just want to say thank you for taking the time today with so few people producing this. I really do. No, I'm serious. I understand the tension, and just thanks, because that's going to help me as a school board member make some decisions that we're facing this summer over what we're going to do for the fall. Because I don't care what anybody says, COVID may be tamped down by then. I doubt it, but we still have flus that go around. We still have everything else that goes around. You still got mold concerns like you guys described. I'm a mold litigator, so I understand all that. But the point of fact is, thanks just for putting this on for so few people.
Very well. Well, I'll mention real quick. I mean, Donald, your point is really valid. Is that COVID? Hopefully we'll get that under control. But indoor air quality, it impacts. One of the big things that the EPA Tools for Schools is always focused on is asthma. And I don't remember exactly how schools are funded, whether it's done on average daily attendance numbers or not, but EPA has worked and has some great success stories of districts that have implemented indoor air quality management programs. And because their funding model was tied to average daily attendance, when they got their indoor air quality under control, they got all their asthma management under control. Their average daily attendance increased, 5, 6, 7%, if not more. And that was millions of dollars a year to the district by their investment in something. And so it was a win-win-win for everybody, because the dollars allowed the district to continue to offer great programs and expand things. The burden and the cost of implementing the indoor air quality program and doing the medical outreach with the asthma management program was not that significant compared to the amount of money that they brought back into the district by improving that average daily attendance.
And here in Michigan, we have 2 days. We have a count day in the fall and a count day in the spring, and they do a blend every year. It changes. But when I was pitching to the board that we look at different things to improve the indoor air quality, I said, look, if we can go out in this world of what we call schools of choice here in Michigan, where you're competing for students throughout the
Right.
county. And we can say, we have the best indoor air quality, boom, we're going to get more kids.
Right. I encourage you to take to hit the EPA Tools for Schools website, and there's lots of fantastic resources there.
Thank you.
Yeah, I mean, student performance will improve. Teacher satisfaction will. I mean, I've heard horror stories from teachers about them getting sick, even getting cancer in their schools just because of poor indoor air quality. And I believe it. So there's a lot of things we can fix with, just like Ian said, simple, cost-effective ways to do it. And I'm really happy to hear this discussion. It took a pandemic to maybe for people to listen, but we have the ears. So now let's say it loud.
Yeah, we tamped down flu this year because the kids are all wearing masks. Woo!
Absolutely.
Point. Well, I want to thank everybody again for participating and sitting in. We do summarize all of this and send it out to a fairly extensive mailing list. So more people will have this, as well as a link to the presentation. While we didn't have a large number of participants today, certainly we do get a lot of people looking at the summary and the video of the presentation. So your participation is deeply appreciated. I think on the next slide, it just talks about when the next, there it is, the next town hall will be on May 19th, and we will be sending out invitations and identifying what the topic will be for our next town hall meeting next month. So with that, I once again want to thank everybody and appreciate your participation, and look forward to having you join us next month. Thanks again.
Thanks, everyone.
Thank you.
Again, many thanks.